Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. We are going to discuss about the topic Fourier transforms. In detail, we are going to discuss through this video lecture the definition of Fourier transforms, and we are going to solve the problems using Fourier transform formula. The definition of Fourier transform, that is, if f of x is the given function, it is a theory, it is a definition, that's what f of x it is there. If it is in the problem, f of x is sin x or cos x or e power x, any trigonometric functions or algebraic functions or exponential functions will be given in the place of f of x. So, the Fourier transform of f of x is defined by the capital F represents Fourier transform. That is, here it is written the notation f of x. The capital F is Fourier transform of the function f of x. Suppose if it is given sin x, the function is there, then we will write f of sin x. The meaning is how we will read Fourier transform of the function sin x. As it is the definition, in general, we are using f of x. So now, how to read this? So Fourier transform of the function f of x, it's nothing but the function, that is our f of x, which is multiplied by e power ipx, and we have to do the integration with respect to x and integrate between the value minus infinity to infinity. This is the definition of Fourier transform. Simple way we can say, whatever the function is given, which is multiplied by e power ipx, and we have to do the integration with respect to x and range between minus infinity to infinity. So we will do now, concentrating on the problem. Find the Fourier transform of f of x. The function is given cos x. Some condition is put. What is that condition? That is, if mod x, modulus function, mod x is less than or equal to a, then this f of x is defined by cos x. Whereas this mod x, if it is greater than a, then f of x is 0. This a is greater than 0, then mathematically it is a positive number. This function we have to find Fourier transform. This is the given question. So we will solve it. So the question, it is find Fourier transform. The first we will start with the formula of Fourier transform. That is, the Fourier transform of f of x is given by, this is the formula, that is f of x equal to integral minus infinity to infinity f of x, which is multiplied by e power ipx dx. Yes, this is our question. Now our f of x is cos x. Again our f of x is 0, 2 are given, satisfying these conditions. But ours is the integral minus infinity to infinity. Then what is this meaning of mod x less than or equal to a? Exactly, if it is the question it is given, here the condition minus infinity to infinity, straight we can replace this f of x, in the place we can put it cos x. But now it is not possible, because strictly the formula is minus infinity to infinity only it is valid, whereas our problem function mod x is less than or equal to a. Then what is the meaning of that? Mod x is less than or equal to a. Yes, minus a. That is, x lies between minus a to a. Then this is cos x, the function. Remaining everything. Mod x is greater than a. That is from a to infinity. Then this function is 0. So we need now, according to our problem condition, those we have to modify. Some changes we have to bring in terms of this integral. Yes, what we have done it. That is, mod x is less than or equal to a. The meaning is x lies between minus a to a. Keeping in our mind that we have to insert our minus a and a between this minus infinity and infinity. That we have to do it. So we inserted minus infinity to minus a to a to infinity. Whether we inserted correct or not, because if we do mistake here, the mistake is committed here, the error occurred here, then entire the problem what we are going to do, we can't get the solution. We will be under in a confusion state. So better we can recheck ourselves what we inserted, it is correct or not. It is a fraction of second. Yes, minus a we inserted. Here we can see it. Up, down. Up and down. The leftover is, here I am circling, minus infinity to infinity. That's what our formula. Yes. Now, here, what is this meaning? X lies between minus infinity to minus a. This is the integral. X lies between minus infinity to minus a. Satisfying this, what is our function? This we know it is strictly x lies between minus a to a. So it is not satisfying this. That means it falls this one. According to this, the function is 0. So f of x is replaced by 0. Fine. Next, here we are seeing x lies between minus a to a. Exactly. It suits to our, this is the first condition. That is the reason here f of x is replaced by cos x. The next, this meaning is x lies between a to infinity. X lies between a to infinity. Here it's not there. So now that falls under, here this meaning is a to, the starting a, up to where the ending, infinity. So the function is 0. It is replaced by 0. So our given, the formula Fourier transform minus infinity to infinity, satisfying our problem condition in such a way it is splitted. The given, the formula is one integral. It is splitted into 3 integrals. In that, our conditions we applied, the first and third integral doesn't exist. Only the second integral, that is the middle one, only exists. Yeah, this is the integral only exists. Now just simply we have written just convenient purpose, just 2 3s are, we can write 3 2s are, both are same. So now cos x into e power ipx, just we wrote it e power ipx cos x dx. This we have to do integration. One is exponential, another one is trigonometry. This we have to do integration, the formula which is available, that we can use it. This is the formula, that is integral e power ax cos bx dx, which is nothing but e power ax by a square plus b square into a into cos bx plus b into sin bx. Now, this formula we will do comparison with our problem. Comparison doing, what is A? In the problem A place, in our problem what is there? IP is there. Here in the formula B is there. What about our problem? 1 is there. Cos x, default cos 1x. So the B is playing the role 1, A is playing the role IP. So we did our problem integration comparing with our formula. We identified A is IP, B is 1. That we are going to substitute in the formula. We substituted. Yeah, we can check it whether it is correct or not. So now A place we substituted e power ipx. Fine. A square. A is nothing but IP. That means I square P square, it's nothing but A square. What about B? B is 1. That is 1 square. That is 1. Here A, IP, cos bx, that is cos x. Our B is 1. Sin bx, our B is 1. That's what sin x. Here 1 is there. 1 into sin x. That's what it is not written. So we applied the integral formula, the combination of exponential and trigonometry. We applied our problem in the formula place. What is that? A and B we substituted. The integration we completed. So now the limits minus A to A. That's what our problem limits, minus A to A. So now the upper value is A minus the lower one is minus A. In the place of x we have to substitute. The reason for x place we are substituting, because here one more p also is there. We can't substitute in the place of p. The reason, we did the integration with respect to x. So with respect to x we did the integration. That is the reason in the place of x we should substitute the limit values. Yes. Now we can see it here. The upper one is A, e power IPA. Here we substituted I square. It's nothing but minus 1. I square, P square. I square value is 1, minus P square. That's what here. Minus P square is there. This plus 1 is written as it is. Fine. So IP. This is cos x, that is cos A, fine, plus sin A. We completed the upper one is, that is A we completed. Here one minus sign is there. This minus sign is related to formula minus sign. That is, upper a value is substituted in the place of x minus the lower one. In the place of x, we are going to substitute minus a. So now, here x is taking the value minus a. That is the reason here e power minus IPA divided by minus p square plus 1. IP. Here cos x place we have to substitute minus a. But here only cos a is there. It should be here cos of minus a. But it is written cos a. It is correct. But how it is correct? The question, the doubt is ringing. Why it is correct? It satisfies the trigonometric formula. The formula is cos of minus theta equal to cos theta. So our cos of minus a, it's nothing but cos a. That is the reason here cos a. Next, sine of minus a, it's nothing but minus sine a. The formula is sine of minus theta. It's nothing but minus sine theta. So here minus is playing the role. X place we substituted minus a. Sine of minus a, it's nothing but minus sine a. We completed the values in the particular places. We substituted and we got these two results. So this is the result. Actually, we got it. The previous slide, this is the last term. So now, 1 by, we can see it, 1 by 1 minus p square. Fine. In this, here and here, IP cos A, IP cos A, the term is common. This is nothing but in the previous slide, the last, the result, it is put it here to save the time, keep on changing this slide. To consume the time, a purpose it is kept here. Now, IP cos A, these two are common. So it has taken here. When it has come out, this is e power IPA. Balance it is written. Here IP cos A, this is kept here. Then what about here this minus sign? Here is their minus. That only here. Next, here sin A is common. That's what it is kept here. So sin A into this e power IPA. And here the sin A e power minus IPA. But here minus is there. How it has come here plus? We should not forget. Here one minus, the outside one minus is there. Both minus into minus, it is becoming plus. The next step, we are going to apply the formula e power ix minus e power minus ix by 2i. It's nothing but sin x. Next, e power ix plus e power minus ix by 2. It's nothing but cos x. These formulas we are going to take help and we are going to replace this one. And same thing, the formula we have to do comparison with our problem. In the formula x is there. Then what about our problem? In the x place, which is playing the role. Yes, the role is played by PA. So according to this sin x formula, our x is PA. So for this, it is going to come sin PA. We can see it here. Sin PA. Here this 2i is missing. That's what we kept it here. It is written 2i sine PA according to our problem. Next, this is nothing but cos x. The same in the formula x. What about our problem? Very simple solving. Problems, mathematics solving, if you are understanding the concepts, it is very easiest one. So the x here, PA. The 2 is coming here. So the 2 cos PA. So we have taken the help from these two formulas. We identified according to our problem, x is playing the role PA. We substituted. Finally, we got this result. Next. Here 2 is there. Here 2 is there. Common. The 2 it has kept to the next line. It is kept out. Remaining all this term as it is. The 2 it has come out. The remaining part it is here. The sin A it is here. Cos PA it is written as it is. Fine. Now it is as it is. I into I square. I square, the value is -1. That's what is a -1 into P minus P cos A sin PA. It is written as it is. This term also sin A cos PA written as it is. Next, 2 by 1 minus P square. Just actually we interchanged the terms. Usually we used to write the positive terms first. Up to here, if you stop the solution also it is correct. If you want, we can rechange it. This is the term, it is written here first. This is written second. So we completed one problem. The next one we can move. Find the Fourier transform of f of x equal to 1 by 2a for mod x is less than or equal to a. If it is 0, mod x, yeah, it should be there actually, it's greater than a. So now this problem we have to solve using Fourier transform. First, the Fourier transform of f of x is given by the formula which we have written, that is f of x equal to integral minus infinity to infinity f of x e power ipx dx. Next, according to ours, formula is minus infinity to infinity, but our problem, mod x is less than or equal to a, the function is here 1 by 2a. The previous problem we discussed with some trigonometry cos x. Here the function is different. But mod x is less than or equal to a, the definition of modulus function is x lies between minus a to a. If it is there, the function is 1 by 2a. To fit this one, we have to modify our integral, that is minus infinity to infinity. How to modify? So minus infinity, that is minus a to a, which to be inserted. To be inserted. So minus infinity to minus a to a to infinity. We can check it whether we inserted correct or not. Minus a up and down, a up and down. The left is minus infinity to infinity. Yes, we got the formula minus infinity to infinity. We are moving. We are solving the problem in a right path to reach the destination of solution. Now, what is the meaning of this? minus infinity to minus a. That is, x lies between minus infinity to minus a. What about f of x? Then we have to check our problem. What is our function satisfying this condition? F of x to be replaced by what? It should be replaced by 0. Because this is strictly it is told. X lies between minus a to a, you touch this function. Otherwise, you leave it. Otherwise, the function is 0. So now this f of x should be replaced by 0. The second one, x lies between the second integral minus a to a. Here f of x is replaced by our given problem condition 1 by 2a. The third one, x lies between a to infinity. So now, satisfying this is, the function is 0. Now our first integral, I am putting the star, the third integral, both are vanished according to our problem condition. Yeah, it is correctly substituted here. We can check it. F of x is taking the place 0, the first integral. The second one is 1 by 2a. The third one is f of x is 0. So only the middle integral exists. Now the middle integral is written. The next, the change what we brought in, 1 by 2a we put it. We have written just before the integral because it is treated as constant. We are going to do integration with respect to x. That's what it is, dx. So 1 by 2a, it is treated as a constant. If you want, we can keep it along with the integral. To avoid the confusion, we are keeping the constant before the integral. Now we will do the integration, that is e power ipx. We have to do the integration. So e power ipx, it's nothing but the integration e power ipx divided by the coefficient of x. The coefficient of x, leave x. The remaining is ip divided by ip. Very simple the way we can remember the integration. Now the 1 by 2a, it is written e power ipx divided by ip minus a to a. So 1 by 2a ip, fine. E power ipx, a minus a to a. Just to avoid the confusion purpose, this ip, we are going to substitute the limits in the place of x. We are not going to touch this ip. There is no x term at all. That is the reason we kept it out. How we can avoid the careless mistakes? We can follow few steps. That is also to avoid the confusions, careless mistakes. To avoid, we are not at all related x terms, just we are putting outside. The reason, we are going to apply in the place of x only the limit values. Why in the place of x? Because we did the integration with respect to x. Yeah, fine. Now 1 by, it is written as it is, 1 by 2a ip, upper one is a, the lower one is minus a. So in the place of first x, we will apply it e power ipa. What about this minus? It is not related to problem minus, formula. So upper one we substituted, minus formula minus. In the lower one, the value is minus a. In the place of x, we have to substitute. We substituted and we got it e power minus IPA. The next step, 1 by AP. In this, the AP we kept it out. 2i we brought in. The remaining as it is written. Why we brought this 2i inside? Because the before step, here it is there. We brought out. Again we are bringing inside. What is the reason of it? We got an idea. Better. This is related to some formula. It is there. That formula we can replace in this particular place. Keeping that idea, we brought in this 2i. The formula, it's nothing but e power ix minus e power minus ix by 2i. It's nothing but sin x. In the formula, 2i is there. That is the reason here the 2i, we put it inside. We brought in inside. Now, the formula x is there. What about our problem? AP, it is there. So now, so the particular complete thing it is sin x according to the formula, according to our problem, sin PA. The down AP, we wrote it just PA. So we completed the second problem. We will move to now the third problem. Find Fourier transform of f of x defined by, now 3 are there. That is minus infinity starting. We know it now. We are very familiar with now Fourier transform as we completed now 2 problems. Minus infinity to infinity. Where is here infinity? It is understood that x is greater than beta. That is from beta to infinity. Minus infinity to infinity. But the break is given. That is minus infinity to, if it is alpha, the function is 0. The x lies between alpha and beta. The function is x. If it is from beta to infinity, the function is 0. So now our Fourier transform formula minus infinity to infinity f of x into e power ipx dx. It should be splitted in such a way, minus infinity to alpha 1 time, alpha to beta 1 time, beta to infinity 1 time. So we solve the problem. So the Fourier transform of f of x is given by, so we know the notation, capital F of x. Capital F, Fourier transform of the function f of x. Our f of x is, one is 0, another one is x, another one is 0, satisfying these conditions. So now f of x should be replaced, the 0, x and 0, straight it is not possible to replace. Because the formula is playing the role minus infinity to infinity. According to this, our problem condition, this integral should be written first. Yes, now we have written it. That is minus infinity to alpha. The first one we completed. Next one, alpha to beta. The second one we completed. The third one, beta to infinity. So our given this formula, the Fourier transform formula, it is splitted 3 integrals. Now after splitting these integrals 3, we have to check x. What is this meaning? X lies between minus infinity to alpha. Satisfying our given problem. Where is the condition? Yeah, the first condition is there. Minus infinity to alpha. What about our f of x? The given problem, it is given clearly the function is 0. Then f of x we will replace by 0. Find the first integral is vanished according to our problem condition. What about the second integral? The second integral is x lies between alpha and beta. We will do the comparison. Alpha, x lies between alpha and beta. Exactly it is matching with the second one. So the f of x is replaced by x. The third one, x lies between beta and infinity. So from beta to infinity, the function is 0. So we can see it here. The first integral is 0. The second one is x. The third integral is 0. So we can see it whether we inserted it very correct or not also. Alpha, alpha, beta, beta. So minus infinity to infinity. So we can, it is actually written dx this is. So it is written actually as it is. Okay. Now, so this middle integral exists. This to 0 into anything, we know it, it is cancelled. Here 0 into anything, it is cancelled. Just this step is repeated again. Yeah, now this we have to do this integration, that is x into e power ipx. One is algebra, another one is exponential. The combination of exponential and algebra. The first problem we discussed, exponential and trigonometry, we used the regarding the trigonometric formula, we solved it. But this one, exponential with algebra, this integration how to do? So x into e power ipx. This is only we have to do the integral. X, the differentiation we know it, 1. Immediately the doubt will come. We are doing integration. Why the differentiation is coming, playing the role here. X, I have written differentiation only. Next, e power ipx. Just once again I'll write it. X, the differentiation is 1. E power ipx, I will do the integration by ip. This again I will do the integration I square p square. Now I'm going to stop this procedure. Why I stopped it? The reason is one differentiation is 0. The simple integration, the step to be followed strictly when exponential and algebra related the terms are coming, we can follow. This is a very simple way we can do the integration. That is, from the integration, we have to pick the algebraic oriented part. That is x, I picked it, x. The differentiation we have to do going on. Exponential one, integrate and we have to write. That is e power ipx by ip. Again we have to do integration. E power ipx by ip. Already ip is there. So I square p square. One more time, I no need to do, because here the differentiation side, the 0 it has come. That is the reason the integration, it is not done. The work is stopped here. Now, very simple thing, these two we have to multiply. Yes, you can see it here. Minus, this is formula minus. And these two we have to multiply. That's what it is written. Suppose one more term it is there, then it will be, this procedure will be extended. So now, you can see it also, we can recheck it. that is x1 differentiation. This is going on, we did the integration. So we completed the integral, that is x into e power ipx dx. It should be used strictly exponential and algebraic oriented. Otherwise, trigonometry and algebraic oriented, we can use this procedure. So now we completed the integration. Now we have to apply this limit alpha and beta. The upper one is beta and the lower one is alpha. So we can say it here, the changes what we have done it here. Minus is there, but here plus is playing the role. The reason here, if we notice it here, I square is there. I square, the value is minus 1. Already minus is there. So minus divide minus, it has become plus. Remaining all the terms are written as it is. Now alpha, beta. So first we will substitute in the place of x, beta we will substitute it. That is beta e power ip beta divided by ip. That is in the place of x, we substituted beta. Next, here x place we substituted beta. That is e power ip beta by p square. So the upper limit totally we completed. This is formula minus. The down one is alpha. So x place we have to put it now alpha. So alpha e power x is taking the role of alpha. So ip alpha divided by ip. Here x is taking the value alpha. So e power ip alpha divided by p square. Next, what are the changes we brought in here? Up to here, it's very clear. Now, the first one, beta as it is, e power ip beta as it is, here the p also as it is, but only the change, this 1 by I is there, that up we brought it, minus I we wrote it. You can write it mathematically. That is the change only. In the first term it is there. Second term there is no change at all. Third term, same. Here 1 by I is there, minus I. Already here 1 minus, it has become plus. This minus we brought here, minus into plus, here minus. This entire term it is written as it is. We didn't do any changes. Now, I by P we have taken common out. Now this I by P, where it is? I by P. Here is there. Here is there. I by P. So remaining this alpha that we brought it here. Alpha into e power ip alpha. Here I by P it has come out. The remaining is minus beta e power ip beta. Fine. These two terms are there. Just I am putting the tick over there. So 1 by p square is common. So it has been taken out. So the remaining, that is here, e power ip beta. Fine. Here the balance one is minus e power ip alpha. So we completed that problem also. We will move to the next problem. Find the Fourier transform of f of x equal to e power minus mod x. Here nothing, no condition is given. So far we did the problems, the conditions are given. Just it is given in this question, find the Fourier transform, the function is e power minus mod x. So we will start solving this one. The Fourier transform of f of x is given by, so capital F of x, how we will read? Fourier transform of the function f of x, it's nothing but integral minus infinity to infinity f of x into e power ipx dx. Our f of x is e power minus mod x. Minus infinity to infinity. There is no change at all in this particular problem because in the problem there is no condition about the integral limit values. So we have to formula as it is minus infinity to infinity. Only that f of x should be replaced by our given function. So we replaced it, that is f of x is e power minus mod x into e power ipx dx. So this is the modulus function which is given. So the definition of the modulus function, if it is plus x, x is greater than or equal to 0, minus x, x is less than 0. So that we are going to apply it. This particular problem, in the question it is not given, but the function it is given only mod x. Mod x, the definition, what is the rule, we must know it. If x is greater than or equal to 0, the function is plus x. If it is less than 0, the function is minus x. So the 0 should be inserted in between this minus infinity and infinity. So minus infinity to 0, 0 to infinity. Here e power minus mod x is there, but how it is written here e power x? A genuine doubt it is coming in our mind. That is, here the meaning is x lies between minus infinity to 0. That is, x is less than 0. X is less than 0, the function is minus x. So the mod x is playing the role minus x. Already minus 1 is out. So minus x, it's nothing but plus x. The second one is x lies between the integral 0 to infinity. So x is greater than 0. Greater than 0, the function is plus x. So the mod x is replaced by plus x, already minus is there. So that's what it is, e power minus x. So if the question, the intervals are not given, just it is given modulus function, we should know the definition of modulus function. So now this is the last step of the previous slide. Here e power x, e power ipx it is there. Exponential law, that is a power m into a power n equal to a power m plus n. Yes, we applied that exponential law. So e power x plus ipx, it is written here. Here, same the law, e power minus x plus ipx, it is written. So minus infinity to 0. In this both x plus ipx, x is common. We have taken out, so the remaining 1 plus ip, it is kept here. E power 1 plus ip of x dx plus integral 0 to infinity. Here minus x plus ipx is there. Minus we have taken out. Minus we have taken out x minus ipx. Next, x we are taking out 1 minus ipx. That's what it is written here. Now we have to do the integration. So e power of 1 plus ip of x. The simple integration, that is with respect to x, e power of 1 plus ip of x divided by x coefficient, that is 1 plus ip. That is the simple integration. Here we can see it, e power 1 plus ip of x divided by that coefficient of x, minus infinity to 0. Fine. The same rule here also. E power minus of 1 minus ip of x, same as it is written, divided by coefficient of x. Coefficient of x, x we will leave, the remaining will come divided by. That's what it is written here, minus of 1 minus ip. 0 to infinity. E power 0, the value we know it 1. E power minus infinity, the value is 0. Now we will apply it. 0 first we are applying, the upper one. In the place of x we are substituting. So e power 0, the value is 1. So the numerator, it is becoming 1. The denominator, it is written as it is. So 1 divided by 1 plus ip. This is formula minus. Next, the lower one is minus infinity. In the place of x we are substituting. It is becoming e power minus infinity. Already we discussed e power minus infinity, the value is 0. That's what here it is written. 0, the lower, the complete value, it is becoming 0 after substituting the value of minus infinity in the place of x. The first integral, we did integration, we substituted the values. Completely, the job is over regarding the first integral. Now we will move to the second one. That is, now the upper one is infinity. So e power minus x place we are putting infinity. So e power minus infinity. We can notice it here, this minus sign, that is problem minus sign as it is written. E power minus infinity, the value is 0. So the upper one, when we are substituting in the place of x, we got the value 0. Minus, but here it is written plus. This particular, while applying the limit value, we know it, upper limit minus lower limit. Upper we substituted, we got it 0. This is the formula minus. The lower one, when we are applying 0, e power 0 we are getting 1 divided by, here minus, this is problem minus 1 minus ip. This minus put together, it has become plus. So in this particular thing, this area, careless mistakes to occur, chances are more. The reason is problem minus also coming, formula minus also playing. Both are playing a role. Such a situations, we have to be very careful. Now 1 minus 1 plus ip, here 1 by 1 minus ip. So just the simplification, cross multiplication, it is done. ip cancelled, 1 plus 1. So the numerator 2 we got it. This is a plus b, a minus b. We know the algebraic that formula. A plus b into a minus b. It's nothing but a square minus b square. Immediately we have to do what is our a in our problem. In our problem, our a is 1. So that's what 1 square. What about our b? B is nothing but ip. That means I square p square. So why it is written here plus? That is the next question it is coming. That is, we are substituting 1 minus I square p square. 1, but I square value we know it, minus 1. Already minus is there, plus p square. So we completed this problem also. So we will come to a conclusion of this video lecture regarding Fourier transforms. So first we discussed the definition of Fourier transform of f of x. That is, capital F represents Fourier transform of the function f of x is integral minus infinity to infinity f of x e power ipx dx. Problems we concentrated. The first one, the function f of x equal to cos x, the trigonometric oriented function we have taken, we solved it in detail. Next, we have taken 1 by 2a, constant oriented, the function we have taken, the second problem. Third one, x lies between minus infinity to alpha and x lies between alpha to beta. X is greater than beta, that is from beta to infinity. All these three problems, this formula minus infinity to infinity, how it is fit according to our problems in detail, it is discussed. The last one, here the interval, it is not given, but if it is not given, regarding the function, any definition is there that we have to recollect, recall, and we have to remember, and we have to apply, and we have to do it. For this, the last problem, e power minus mod x, we discussed it. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.